So the recording has started. So our talk this evening is digital manufacturing. Is it the way forward? And Marco Tonnarelli is our speaker. He graduated from the University of Padua in Italy and has worked as part of the team at Protolabs for 10 years. His role is to support customers through product development to decide on the best manufacturing solution for their products. Marco is now Protolabs CNC Machining Specialist. So I will hand over to Marco.
Hello, thank you very much, Brian. So let me share the screen and then we can start. Okay, hope you can see the screen. Okay, so thank you very much. Good evening and welcome to this introduction about digital manufacturing. Yeah, this is the arguments that you're going to have today. Oops, sorry. So this is me. Brian already did the introduction. Yes, I'm Italian. I studied at Padova University, and it's 10 years that I work with Protolabs, supporting the customers to develop their project as application engineer. So today we're going to see who is Protolabs and what is digital manufacturing, why is important to use digital manufacturing. We will see some of the processes, and then we will have some case studies. At the end, I will give you some additional resources, and of course, I will be happy to answer your question at the end. So I suppose you have already heard about Protolabs. To see who is Protolabs, I'd like to show you this video first. You can see this is our facility here in the UK. All right, so that was Protolabs. Protolabs was founded in 1999 by Harry Lukis in Minnesota, USA. And after that, we have expanded through USA and in Europe. We have a production site in UK, the one that you have just seen, another one in Germany, and we have other commercial offices in Sweden, France, Italy, Germany. Those are the green dots that you can see. And on top of this, we also have a network of manufacturers that you can see represented by the blue dots, and they are in North America, Europe, China, and India. We will review that later on in the presentation. So let's see what is digital manufacturing. You may have already been in contact with that, but let's clarify a little bit. So this is a visual representation that can give you the idea how the product development works and well, how the digital manufacturing fits with that. So imagine that you start with your idea, then you start drawing something. Eventually, you come about with a CAD model, maybe an assembly, then you need to find someone that is able to produce what you have designed. So you can upload the CAD model directly into our website and our system, and then you will receive immediately, or worst case within 24 hours, you will receive our feedback in terms of costs, lead time, but also in terms of DFM. So the design for manufacturing means that we will highlight you the possible risk of your feature, of your design, things that may work, things that may be critical, may not work too much. And after you receive this feedback, you can then think to maybe adjust your design, review your idea, go back to the drawing, and then upload another assembly, another CAD model, and so on. When you are quite confident that what you see is exactly what you need, then you can go into production, order a few parts, review these parts, maybe start your test, your verification. And then again, depending on what is the feedback, if everything is fine, you can continue with production, which is the loop on the right. Otherwise, you can go back, rethink your idea, adjust again the design, and go on with the process. You may already start thinking why digital manufacturing is important when it is important. The main key factor that you can see here is the lead time. In this way, you can forecast the possible problems or challenges that you may have much earlier before even you spend any money on sampling or on production. You can see here the time to market with digital manufacturing is about 6 months, while traditionally it could be 12 months or even more. So you will have savings in terms of money, saving in terms of time, and also you can start your verification and validation much earlier than in a traditional manufacturing system. So this will means that you can see problems and be able to solve problems much earlier and get to the market with quite a solid solution, be the first to the market, and this will give you a very high competitive advantage. Here you can see this is what I mentioned before, the DFM, so the design for manufacturing. This is an example of an injection molded part. You upload the CAD model, and you can see we highlight, for example, in this case, the jet location. You can see exactly where we are going to place that. You can see where the gates will be placed for injection molding. The different colors represent the different components of the tool. You can see the thick areas where the parts may be at risk of sink, thin areas, again, where the parts may not be formed. So you will receive these DFM for every single part that you upload and every single process. A brief description of what is the issue and possible ideas to solution. But of course, you can always talk to a human being. You will have a dedicated account manager, and also you can book a meeting with me or any of my colleagues so we can review in details your part. You can tell us what are your ideas, your constraints in terms of application, and we will review from our manufacturing point of view, and we will find out a good solution that will work for both parts. I've mentioned already a bit about the manufacturing processes. So there are 3 main manufacturing processes that we work with. The first is 3D printing. Generally, 3D printing has the digital manufacturing process. It's not the only digital manufacturing process. 3D printing is an additive manufacturing. So it means that we build the parts layer by layer. We can start from a powder or a liquid polymer, and we can build your part, exactly the CAD model that you have uploaded. This is for plastic and for metals. There's no minimum order quantity. Minimum order quantity is just one part. There's no tool involved, so it's very cheap, very cost effective. and the lead time also is very short, from 1 to 7 days. It's very cost effective, as said, for small quantities, so it's very good at the early stages of your product development, so you can see the first parts and start to verify how they work. Of course, for high volume, it's not always competitive, this system, although I have to mention that for metals, for the direct metal laser sintering, there are many cases of these parts being used in real application, for example, in the aerospace industry, because of the lightweight, so the weight, the weight reduction is very important in that case. So that's why DMLS it's used in these cases. The other manufacturing process that we can offer is CNC machining. This instead is subtracting manufacturing, means that we start from a block or a rod of plastic or metal, and we remove the material to obtain the geometry that you have uploaded. Also, in this case, you will receive the FM. You will see if there's any critical areas, any feature that cannot be machined, if there will be some added plastics and leftover material. This also does not need any equipment, so the minimum order lot is 1, and it's even faster than 3D printing. We're talking about 1 to 3 days, depending on the geometry, and so also very cost effective, and it can be up to 2,000 parts. Generally, it's quite competitive. The advantage here is that you can have the real plastic that you will have for real production. In 3D printing, generally, it's used some resin that are not exactly the same material that you will find in large volume production. And the third one is injection molding, which injection molding has been around for 100 years. But we've been able to redesign, to squeeze this process into 15 days or less. This is exactly thanks to the digital manufacturing. So you can upload your CAD model, and we simulate the production process of the tool and the injection molding of the part, and we can highlight you the critical features, but at the same time we can calculate very precisely what will be the cost of the tool, the cost of the part. And when we go into manufacturing, everything again is related to that. Therefore, we can cut the time and allow the parts to be produced in 15 days, or producing the tool and the part 15 days or even less. Of course, the cost, if we need to include here the cost of the tool, but it's an aluminum tool, so generally it's quite cheap, and we can guarantee the tool for life. So you can reorder as much as you want. We will take care of the tool forever. This is very effective for medium, large volume production, up to 10,000 parts. And as I said, still considered a very fast manufacturing process, especially if you compare with the traditional injection molding time. On top of this, we have secondary services. This is something that is done case by case, because generally, after you have machined some part or molded some part, this is never the end of the job. There's something else that can be done. For example, we can offer a laser etching, pad printing, spray painting, anodizing, very many different things that are done case by case. So depending on your needs, you will have the possibility, when you upload the CAD model, you will have the possibility to leave note, upload drawings to explain what you want to achieve after the main process, and you will receive a quotation that also take in consideration that, of course, there will be some lead time would be elongating the lead time that we've seen before. There will be some extra costs, but this can be will give you the possibility to customize the part exactly for what you need. And as mentioned before, we also have a network of manufacturers. Basically, we have partners around the world that can cover what is not covered by our standard process. For example, very big parts, out of our envelope, or large volume production. Said before, for example, for injection molding, if you need millions of parts, we are not able to offer it, but there are manufacturers that can do that. Or if you don't need a fast lead time and your main goal is to have very cheap parts, again, through the network, this can be done. Or very specific tolerances, very specific production process also can be offered through the network. The platform works in the same way. You upload the CAD model, you can select what you are needing, large volumes or high tolerances or whatever, and you will receive the quotation for the exactly for the needs that you have. Quality control, of course, is even not worth to mention, but we have quality control through all the process at the beginning till the end. We have certification, ISO certification, the main one, 9001, 14001, but also we have a specific accreditation for specific industry, like medical industry or automotive industries. So in case you are interested, we can support you with that. Many of the projects needs to have an accreditation. So we offer the measurement that will help you to achieve the accreditation that is needed. Now we can have a look. This was the theory. Now we can have a look about some real cases, so some case studies to see what we have done in the reality. This was a very expensive vodka, and we have designed, basically we have realized the 3D printed cap of the system that was designed with just through 2 iterations of 3D printing. Then we've been able to go to injection molding in terms of 3 weeks from the original idea. The part was ready for the market. The second one is a drone, a rescue drone, that is able to help people on the sea that are in danger before the actual rescue team arrives. And in this case, we'll be able to 3D print the body of the drone and allow the company to make the first test, the first validation very early in the development of the project. This is an example of automotive industry. Actually, this is an assembly about 30, 40 components that for CNC, they've been redesigned a little bit to be CNC machined. And in terms of few days, we were able to deliver these component assemblies for the company to make the test. This is a completely different example. This is for the fashion industry. You can see this is a 3D printed part. So this gave the designer full freedom to design exactly what they want. We'll be able, this is a unique example, to print that part that was assembled then into the dress that you can see. So fashion industry and very unique case. This one instead is for medical application, medical device, and noise reduction for elderly people. These were components in silicon rubber and metal. And again, in terms of 1 week from the idea, they were able to test this with a human being and see if the design was correct, to see if the idea was valid. And after a second iteration, probably the part was already ready. This one is a robot to explore the rainforest. A few components in CNC and 3D printing. This gave the possibility of the developer to develop the idea in parallel with receiving the parts. Basically, they were assembly. When they received the parts, they were making the assembly and validate the idea just there and then. So very, very early in stage. This is a coffee machine, actually a high pressure coffee machine, a very, very good idea. We've been able to machine the part and mold other parts in silicon to validate the idea and verify the pressure and also go into production. This is a very high-end product for coffee machine. The next one, this is just a real representation of a virtual equipment in the game industry. Again, a few parts in CNC, just a showcase, a big part. And this is another medical device. Basically, this allows you to cool down where you had the trauma in your head, similarly to when you apply ice when you have a trauma, but in a very controlled way that will not damage your brain. We have molded the case that you can see, the plastic case, and this allowed the team to verify the instrumentation directly in the football or rugby field. So very early in the stage, they had something that they could test in the real environment. Okay, yeah, you can see all these 9 case studies. Just I will give you a bit more of additional resources. You can find all those case studies on our website. On top of this, on the website, you can find many other information about our services or in general about the processes. In particular, I would suggest you to have a look. We have this Spiron Academy. Basically is a course, actually 3 different courses for the 3 different processes. And this is CPD accredited. You can watch the video, read our paper. There is a test at the end of every session. If you pass all the tests, you will receive your CPD accreditation. This is the design cube for injection molding. We have many gadgets that you can order online. This is free of charge, actually. You can request through the website. And this is a case studies for injection molding. We'll show you some of the critical features, exactly something that we mentioned before. And yeah, that's, you can see, this is just the building that we've seen in the video before. It's here in Telford. I'll be happy to answer the question if we have any. I don't know, Brian, if you had.
Yep, we have 2 questions in the chat box at the moment. I'm sure people will be firing more in. So the first, how do you assess DFM
from the model? Yeah, that's
yes.
That's a good question. Basically, there is an automated software depending on the service that you have selected. The software will analyze your part. First of all, the CAD model itself is translated into our internal format. There's a software that our founder has developed a software that is still updated every week. We receive an update. So we have through the software, the part is analyzed and automatically we can calculate what is the time for the manufacturing and the critical areas. Of course, then at the end, for simple parts, the quote is immediate and it's automated. For a bit more complicated parts, the computers can do something, but then there's the need of a human being to review that. But it's more and more, we acquire more and more capabilities in able to analyze the parts, more complicated parts, much faster. So I hope this answers your question. The second one, let me see. How do you make the injection molding tools or the machine from solids or something else? Yeah, we machine the tool. Our tool are aluminum tool. In some cases, we can also offer steel tools, but let's say the standard is aluminum tool because it can be machined very quickly in terms of few days, and it is the 7th grade of aluminum, so it's very resistant, good enough for injection molding. It will through the software we can design, we can analyze the part and design the tool. So when the order is placed, we know already how the tool is done. We simply start machining the different components. We assemble the tool together, and we go to injection molding. It's very simple and very effective. And as said, we can guarantee the tool for life. So if something bad happens, we can replace free of charge. You don't have to take care of that. It looks like many of the projects involve new design. How does the company address any IP aspects, intellectual property aspect? So we have, we can sign non-disclosure agreements before you start any project. This is a standard practice. You come in contact with us, you have a dedicated account manager. So for projects that have this kind of requirements, before we start the project, we can have this legal assignment for intellectual properties. And then after that, everything will be covered by that. How do you manage tolerances, in particular in CNC machine parts? The solid model may not have the data in it. Yes, that's correct. We state in the quote what are the tolerances for the process that has been selected. So you know upfront what are our tolerances that we can guarantee with our fast manufacturing process. Generally, these cover, for example, for a CNC, I can tell you it's plus or minus 0.1 millimeters. So even it's within the norms, even better for bigger parts. So we are, as I said, we covered, let's say, 95% of the requests for very specific tolerances. Of course, we can review in some cases. I mentioned that for very specific application, the network can help us, but let's say 90% of the time we are really in line with the standard tolerances for the processes that you can find as say injection molding, 3D printing, and CNC. Can you detail parts in voids, for example, internal values and baffle in a Venturi liner? So we can, for example, this is probably for injection molding. Otherwise, you can rephrase your question. For injection molding, for example, yes, we can simulate the injection molding process. So we can verify pressure, cold spot, or anyway, I don't want to go very technical, but anyway, all the possible risk, depending on the geometry and depending on the material that is selected. And then our main goal is to show you what are the criticality, and then we can discuss together if this is something that you can accept for your application or for the early stage of your product, or it's something that must be addressed, and then we can think about redesign. We can give you our feedback, our knowledge, how to redesign the part to cover that specific problems, or I don't know, suggest different material, different manufacturing process depending on what is needed. Is any physical material mechanical testing done? If so, then by whom? Let's as a standard, no. Basically, we buy the material. For example, for injection molding, we do not formulate the material for injection molding. We buy from the market. On the website, there's a list of our stocked materials, the main grade that you can find in the market, from the standard ABS, PC, nylon, to the very engineered material like PEI. So you have all the technical data sheet of those materials available. We do not test the material itself or the part itself. We do not have a laboratory, for example, for a fire rating and so on. We just rely on the declaration from the supplier. However, in some cases, for some special project, for example, in the medical industry, I'm talking in specific for 3D printing in the medical industry, from human implantation, the norm required to perform a certain number of tests directly on the part. So in that case, yes, we can offer, but this is a very specific case for a very specific industry, and of course, it has a very specific price. So it can be done in some specific cases, but as a standard, as I say, we rely on also because in the short lead time we can manufacture the part, because the test will require extra time. We have we heavily rely on the manufacturer, what the manufacturer has declared. Don't know if there's someone is typing. Okay, just thanks. Okay, thanks. Thank you very much. Did you say that metal 3D printing can be done? What metal? Yes, we can 3D print in metals. DMLS is the process that we offer, basically from a powder. We sinterize the material with a laser ray, and we offer aluminium, few grade of steel, carbon steel, titanium, brass, copper. So there's huge possibility. On the website, you can see the full list. Also, when you upload the CAD model, you can select the right material. I say this goes in parallel with CNC. Generally, for very simple geometry, CNC is the best way to go because it's cheaper and faster. For more complicated geometry, say, for example, for the aerospace industry, yes, DMLS is the right process. Someone else?
Somebody is typing.
Yeah, let's wait. Thank you very much. Very good question, to be honest.
Yes, I'm not sure whether this is coming through. Can I ask a question while we're seeing whether that does come? Have you noticed any trends with the availability of this service? Has it evolved in a way that because of iterations from customers?
We have started in 20 years, 25 years of Protolabs. We started first with injection molding because that was the critical point. Basically, our founder, Reliukis, was developing himself a new product, and he couldn't understand why he needed 1 week to have a quotation and 3 months, 4 months to have an injection molded part. So he developed this software to reduce the lead time, to automate as much as possible, so that he could offer parts, as said, in a matter of days. After that, we expanded to CNC machining, and later on the 3D printing. So 3D printing is a given that 3D printing is a fast process. CNC and the injection molding has been redesigned in order to squeeze in a very, very short lead time. So Brian, I've answered your question.
Yeah, no, thank you. There is another question there now.
The need for safety critical application like testing is essential. Yes, exactly. So for implantation, we can 3D print part in titanium for body implantation, and yes, that's exactly what is needed. You have an investment in casting option. We do not have vacuum casting directly because it's at the end it's not very cost effective if you consider how many parts you can do comparing to what you can do with our real injection molding process. But in the network, that can be a solution. But generally, as said, by CNC or injection molding, you can get something better than vacuum casting.
Okay, it looks as though questions have run out. I hope that if anyone has any further questions, if they send them to me by email, I will pass them on to Marco.
Absolutely, very happy to answer by email. If tomorrow you come out with something else, guys, drop me an email to Brian. I will be happy to reply within this week. No problem.
Yeah, okay, that's good. There is, I think we'll wrap it up there. So Marco, thank you very much. I found it very interesting. I did actually visit Protolabs. I think it was about 2 years after you'd started in Telford. And it's quite clearly things have developed quite a long way from those early days. But the basic concept of producing prototypes very quickly is still there. And I can see the value, and some of those case studies, particularly the fashion on the dress, was really quite interesting.
Yeah, that's quite unique, to be honest. You're
right. Yes. So anyway, so thank you very much indeed on behalf of everyone. There've been a lot of questions, and if there are more, I will forward them on to you. So thank you very much.
Thanks to you, Brian, and guys, thank you very much, and have a nice evening. Bye.
Right, I have stopped the recording. So I'm not going to turn everything off immediately. So if with a small number, if anyone does want to chat,